Welcome back, everyone. Now we're going to dive into some questions because that's the best way to learn, is to just practice and practice and practice. Okay, so here we go. I have a ball that is thrown up from the balcony of a building. The ball reaches its highest point, then falls to earth after passing the balcony on the way down. Now they want us to draw a position versus time graph, a velocity versus time graph, and an acceleration versus time graph. What they haven't said to me is which direction we want as positive. That makes a difference. So now we got to be careful. We need to make a decision and stick to it. We can't change halfway through. In some questions, they'll say to you, they'll go, this is the direction we want as positive. That's the direction you must work with. I like to draw a little sketch so I know what they're saying. So they're saying to me, I've got a balcony, the ball gets thrown up and then it comes back down. They haven't given me values, they haven't told me anything about that. So what we're doing here is they just want the shape. Now, if I have a choice, I like to take original direction of motion as positive. So for this one, I would like to take up as positive, which means acceleration is minus 9.8 meters per second squared, and it's minus because it's going down. So let's draw the position time graph. Position, which is m, okay, time in seconds. Now, I don't have any more detail. It's a sketch. What are we looking for? Shape. I've taken up as my positive direction. That means my graph, the 0 point is the balcony. It's going to go up and get slower and slower and slower. Then it gets to its highest point, then it gets faster and faster and faster and faster, and it goes below here. This is what they're looking for. Gradient getting less steep, gradient getting more steep, and going past where it started, because the final displacement is going to be negative. It ended below where it started, and I said up was positive. So it's got to have a negative displacement at the end. That's very important. Now they want the velocity time graph. Okay, so velocity time. What happened to the velocity? Well, I threw it up, so it had an initial velocity. That velocity got smaller and smaller and smaller, stopped, changed direction, and came back down and got faster and faster and faster. So I know this has to be a straight line crossing the time axis, but here's the trick. Here we go. Crosses the time axis, but the second part, this part of the graph, must be longer than the first part, because it went further than when it started. So we've already done the fact that if it goes up and comes down to the same place, the velocity is the same when it leaves and gets here. But now it goes past that starting point. Because it's going past that, it's going to go faster and faster and faster and faster. So it's still a straight line because my acceleration is constant. That gradient is my acceleration, and that's the same for the whole way through. The issue is how long it goes for, okay? Then we get to the easiest out of all of these, which is my acceleration time graph. We like these. So, time, acceleration. Now, I'm hoping what you guys have noticed every time I do one of these sketch graphs is I always label the axes, okay? you must label the axes, otherwise it's just random lines. It doesn't make any sense. I can't get anything from it. So make sure you label your axes. You only need to put values on your graph if you know values and if they ask you. Sometimes they don't want the values. All they want to know is, do you understand the shape? So be careful. Don't put extra stuff on the graph because you're going to waste time calculating stuff that you don't need, but don't stress that you don't know the values. We're looking for the shape. We're looking for whether you understand the motion through the graph. Now here, I can put a value on. Because I know acceleration due to gravity is always the same, I took up as positive. So I know that's minus 9,8. That's a given. And it's a straight line. No matter what happens, it's a straight line, which is great. We like this. This is nice and easy. Okay, so here we go. Next one. A man fires a projectile. It can be anything, okay? Vertically upwards, there we go, with a velocity of 29,4 from the edge of a cliff. So again, I've got the edge of a cliff, he's thrown it up, and then it comes back down. The height of the cliff is 100 meters, so that's going to be a displacement. After some time, the projectile lands on the ground below the cliff. The velocity time graph, which you'll see next, shows the motion, and it's not drawn to scale. They put that in because sometimes we think when we get a graph in an exam or a test, or we look at it and we go, it's not quite, doesn't feel like it's right. It's okay, it's not about that. You're going to get important pieces of information from the graph, and that's what we're using. So here's the graph. So this is what we know. Initial velocity, 29,4. They're saying to me over here that that's how long it takes to get to its highest motion, and then it carries on down. What they're telling me in this graph without putting it in words is they're telling me which direction is positive. Here, they tell me initial velocity is plus 29,4. I know I threw it up. I have to take up as my positive direction throughout this question. I don't have a choice. And this is why I don't want you to learn that down is always positive or up is always positive, because then when they change in the question and they decide what is positive and negative, it gets a bit confusing. So make sure you can work with both, okay? So, question says, use the graph, very important term, use the graph. Maybe I should have a pen. Use the graph. Use the graph means calculating area or calculating gradient, okay? You cannot use equations of motion. If it had just said determine, you can do it how you like, or calculate, you can do it how you like. Area, gradient, equations of motion doesn't matter. But they said use the graph. They are specifying the way they want you to do it. Why? Because we're testing a skill. We're testing an understanding. Okay, it's not just to make your life difficult. Okay, it really isn't. So, use the graph to determine the time that the projectile takes to reach its maximum height. Actually, we can just read it. 3 seconds. No calculation needed. Bonus. We like those. Calculate, and we're using the graph for all of this, the maximum height the projectile reaches above the ground. That is this area. Okay? So we want delta y, which is the area under the graph, which is now a half, times base times height. So it's a half. My base is 3. My height is 29,4. I most certainly cannot do this in my head. So I'm going to, let's get rid of this. A half times 3 times 29.4. And I get 44,1. That's nice. Not so bad. Oops, I'm going the wrong way. Then they want the sketch of the time graph. Well, we know how high it went. Okay, it took, so this is my position time graph. I know it went up and it came down. There's my 6 seconds. There's my 3. They didn't ask me to put the value in, so I'm not going to worry about it. And that gets us to the end of that one. Wasn't as bad as it sounded, correct? So we're going to take a short break, and I'll see you in a couple of minutes.